Alright, so let's do a little bit challenging problem from variation of parameters for systems. Okay, so we have this problem. Now what you want to do first is you want to solve the homogeneous version of this system, right? So x prime is equal to -2, 1, 1, -2x. So you want to solve this problem first. That means find the complementary function. Now to do that you have to find the eigenvalues and eigenvectors. So I have done it beforehand. So the eigenvalues are lambda 1 is -3, lambda 2 is -1. You should do this by yourself. Try to pause the video and try to convince yourself, try to get the same results. Okay, so the eigenvectors are 1, -1 and 1, 1. So then we can really write the complementary function as C1, the first eigenvector, 1, -1, e to the -3t, plus C2, 1, 1, e to the -t. So this is the complementary function, solution to the homogeneous system. Okay, now what you want to do is to find the particular solution. First find the fundamental matrix, right? So the fundamental matrix phi is actually 1 times e to the -3t. So here e to the -3t, here -1 times e to the -3t, negative e to the -3t. Here it's just e to the -t, e to the -t, right? So we write the fundamental matrix using the complementary solution. Now what you want to do is find the inverse of phi. So inverse is, first what you do is you change these two. Okay, you exchange these two, e to the -t, e to the -3t, and you multiply these two by -1. So this becomes e to the -3t, this becomes negative e to the -t. Okay, so now, well, we are not yet done with phi inverse because you have to divide this by the determinant of phi. So determinant of phi is, first you multiply these two, so e to the -3t times e to the -t minus, now multiply these two, negative e to the -3t times e to the -t. So e to the -3t times e to the -t, you can add the exponents, so you get e to the -40, here minus minus plus, plus here also e to the -40, which gives us 2 times e to the -40, right, when you add these two. So that is the determinant. So you divide by the determinant of phi to get this phi inverse. Okay, so now we want to simplify this. So what we can do really is, okay, so then the phi inverse is really, let's keep this half outside and we divide by e to the -40. We divide all of these by e to the -40. That means you multiply by e to the 40. E to the -t times e to the 40 is here e to the 3t. Here negative e to the -3t times e to the 40 is e to the t. Here negative e to the 3t. Here e to the t. Okay, did I do that correctly? Here we don't have a minus, right? Yes. Yeah. Okay. So this is the phi inverse. Okay. Good. Now what you want to do is you want to find phi inverse times f. So keep that half outside. E to the 3t, negative e to the 3t, e to the t, e to the t times f is, from the non-homogeneous part of the system, we can say f is 2e to the -t, 3t. Okay, so now you want to multiply these two out and you need to find the vector that you get. Okay, let's see. So here, let's keep that half outside. So now when you multiply this e to the 3t by 2e to the -t, what you get is 2e to the 2t here. Okay, and then you multiply negative e to the 3t times 3t, it's 3t e to the 3t. Okay, so that's the first row. Now you multiply e to the t and this, so e to the t times e to the -t, when you add -t plus t on the exponents, it's e to the 0. E to the 0 is 1, not 0. Okay, so it's 2 times 1 is 2. That is a very famous mistake that you can do. So e to the t times 3t e to the t, it's just 3t e to the t. So this is what we get, phi inverse f. Now what you want to do is, really based on the variation of parameters formula, you want to integrate this, right? You want to integrate phi inverse f with respect to t. So to integrate that, so let's keep the half outside again. So you want to integrate 2e to the 2t negative 3t e to the 3t. Here's the challenging part of this problem, the integration. Okay, all right, it's just a little bit of work, really. There's nothing challenging about it. Okay, so let's integrate very slowly. Okay, so let's integrate. Let's keep that half outside. If you integrate e to the 2t here, that is e to the 2t over 2, right? So it's 2 times e to the 2t over 2. Now to integrate here, let's keep that minus outside. So you want to integrate 3t e to the 3t. How are you going to do that? So let me do that here, up here. You want to integrate 3t e to the 3t. You want to use integration by parts. So that's the challenging thing about this problem. So if you use integration by parts, I will choose u to be 3t, dv to be e to the 3t. So u is 3t, du over dt, that means the derivative of u with respect to t is 3. So du is 3 dt, and v is actually e to the 3t over 3. So by using the formula uv minus integral of v du, u is 3t, v is e to the 3t over 3 minus integral of v to the 3t over 3 times du is 3 dt. So here 3 cancel out. So what we get is integral of here what we have is t e to the 3t. Okay, here this negative and this negative plus. Okay, so then what we get is e to the 3t. If you integrate e to the 3t, you get another 3 down. So this is what we get. Okay, so that's what we get after integration. That's after integration. So we don't have integral sign. So that's what we get after integrating the first row. Now if you integrate 2 here, that's 2t. Now plus you want to integrate again 3t times e to the t. So that's also again integration by parts. Okay, so it takes a little bit of time. 3t e to the t dt. So again u is 3t, du is 3 dt. Okay, that's same. dv is now e to the t, so v is e to the t also, because integral of e to the t is e to the t. So now if you use the formula, u is 3t, v is e to the t, minus v du is et 3 times dt, that's du. So if you integrate here, you get 3t e to the t. Here you integrate here, that's also 3 et. So this is the answer. So let's put that here, 3t et minus 3 et. So that's the integral. So the challenging part here was that this integral was long because you have to use integration by parts. Okay, so this is what we get. So let's try to simplify it. Okay, so let's keep this half outside. So 2 cancel out, so it's e to the 2t minus t to the 3t plus e to the 3t over 3, 2t plus 3t to the t minus 3 to the c. No, we cannot simplify furthermore, right? So that's all we can do. Okay, so we found the integral of phi inverse times f. Now the final step is to multiply what we got from phi. Okay, so this is what we got. Now we have to multiply it by phi. So phi is e to the negative 3t. This is the final step, e to the negative t, negative e to the negative 3t, and here e to the negative t times, let's keep this half outside. Okay, this times e to the 2t minus t to the 3t plus e to the 3t over 3, 2t plus 3t e to the t minus 3et. So if we want to multiply these two out. Okay, so this is the last step. So let's do it. Okay, it's going to be over soon. All right, so let's see. So let's keep this half outside again. It's going to be long. So e to the negative 3t multiply this whole thing. So e to the negative 3t times e to the 2t is e to the negative t. Okay, e to the negative 3t times here. So e to the negative 3t times e to the 3t is e to the 0, right? If you add the exponents negative 3t and 3t. So e to the 0 is 1, so it's just negative t here. Here also e to the negative 3t times e to the 3t is e to the 0, which is 1, so this is 1 over 3. So that is what we get. Plus, now don't forget, you have to multiply e to the negative t and this all. So e to the negative t times 2t is, it's 2t e to the negative t. See, it's long, hopefully it simplifies out. 3t times e to the t is just e to the 3t, e to the negative t, and e to the t is e to the 0. Here minus 3, so minus 3 from here. Okay, now here you take negative e to the negative 3t times the first row, which is same this row but multiplied by negative, right? So you can multiply it out. So it's negative e to the negative t plus t minus 1 over 3. Okay, now e to the negative t times this row is actually 2t e to the negative t plus 3t minus 3. Okay, so that is what we get after multiplication. It was a low multiplication. So let's see what we get. The particular solution is half. Let's try to simplify this. So here e to the negative t, nothing much you can do with that. Negative t and 3t is 2t. Okay, and then 1 over 3 minus 3. 1 over 3 minus 3 is negative 8 over 3, I believe. Right? Yes. And then 2t plus 2t to the negative t. Well, we cannot simplify more than that. It's okay. That's our solution. So minus e to the negative t here. T plus 3t is 4t. And then negative 1 over 3 and minus 3 is minus 10 over 3, I believe. Yep. And then plus 2t e to the negative t. So this is what we get, the particular solution. It was a long process, I know. I think it made complicated with the integration by parts, and I think I would say this multiplication you have to be a little bit careful. Okay, try to do it by yourself and convince that you get this same answer as me. Okay, so now we have the particular solution. Let's really finish up the problem by writing the general solution. So general solution is complementary solution. C1 1 negative 1 e to the negative 3t plus C2 1 e to the negative t plus the particular solution, which is half. Okay, I need to write this one so that you finish up the writing the general solution like this. So this is a hard, really a hard example from variation of parameters for the systems. Okay, so this is the general solution. All right, thank you.